Alkenes are a good point in our discussion to introduce the concept of elements of unsaturation. Elements of unsaturation are basically an analytical concept which comes about from the elemental analysis of organic compounds. Elemental analysis allows us, by using the combustion analysis of carbon and carbon dioxide and water, allows us to tell what's the percentage of hydrogen and carbon and oxygen and other elements in any given compound. And from those percentages we can derive the molecular formula of the type CXHY, which then can answer the question whether we have a saturated or unsaturated compound. And this is really an introduction into analytical methods for discovering the structures of organic compounds that we'll talk about later in the class. But for now, we can derive some general conclusions that alkanes have a general molecular formula of CmH2n plus 2. And that if they lose 2 hydrogens, they will get to an alkene, which will have a double bond, so it will no longer have 3 hydrogens attached to these 2 carbons, but just 2 of them. Or we can get to a cycloalkane, which will have a cycle of some sort, and this will lose the terminal hydrogens. Okay? Alkenes and formally cycloalkanes are known as unsaturated compounds because they don't have the maximum number of hydrogen atoms that is allowed for the given number of carbon atoms. Well, the alkanes are known as saturated compounds because they do have the maximum number of hydrogens for a given number of carbons. Okay? And so we see that we can get from a saturated compound to an unsaturated compound formally by either introducing double or triple bonds or by introducing rings or some combination thereof. And therefore, rings and double bonds represent elements of unsaturation. And for example, we can get from a saturated structure of propane, this is C3H8, into several unsaturated structures such as propene, which is C3H6, or cyclopropane, which is C3H6, or cyclopropene, which is C3H4. And these compounds would have one element of unsaturation, and that would be a double bond and a ring respectively, while this compound would have 2 elements of unsaturation, since it has both the ring and the double bond. Okay? So to calculate these elements of unsaturation, an element of unsaturation is basically equivalent to index of hydrogen deficiency. This is just a synonym for the same thing. We will take the following formula: 2 number of carbon atoms plus 2. This is nothing else than the number of hydrogens in a saturated hydrocarbon minus number of hydrogen atoms and divided by 2. If we calculate this for these structures, then it will be 2 times 3 plus 2 minus 6 over 2, and this will give us 1, whereas here we will have 2 times 3 plus 2 minus 4 over 2, and this will give us 2. So it's all consistent. If we, for example, look at the structure C4H6, we'll realize that this has 2 elements of unsaturation, so here's 2, and then we can derive the various possible isomers which will satisfy this, all of which have 2 elements of saturation. 2 double bonds, 1 triple bond, several isomers for 1 triple bond, 1 ring and 1 double bond, 2 rings, and various other structures. Okay? The extension of this is asking the question, how does this work with the heteroatoms? And there's pretty simple rules can be derived. So halogens, if you think about the structure of halogens, they replace one hydrogen. Right? They're monovalent like hydrogen. One hydrogen. So we should expect one hydrogen less in our structure, in our saturated structure. So if this is saturated, then C2H5Cl will be saturated as well. Okay, so we expect one hydrogen less, minus one hydrogen in saturated structure. If we have oxygen, oxygen basically insert into either CC or CH bonds. Now, of course, this is a formal insertion, which means that we can simply ignore them, that this structure will be saturated, and since oxygen just squeezes in between the existing saturated structures, we can basically ignore oxygens in calculations of index of hydrogen deficiency. Finally, nitrogen, we can look at it as also inserting, but since nitrogen is trivalent, we can look at it as inserting as an NH unit, okay, which means that it will bring one hydrogen more. So if our saturated structure was C2H6, our saturated structure with nitrogen would need to have one hydrogen more, so plus one hydrogen in saturated. And this is really a very straightforward derivation of the valencies of individual elements. So again, index of hydrogen deficiency, or elements of unsaturation, comes from combustion analysis. So these numbers are typically correlated to experimental data, and that's why they're rather important in our analysis, although we will see much more of them later on in the course as we start talking about spectroscopic methods for identification of organic compounds, which then tie nicely with this quantitative measure. In the next subtopic, we will finally get to the nomenclature of alkenes and see how we build up yet another layer onto the nomenclature of alkanes to name these compounds with a function.